Okay, good. Now we are connected. Sorry about that, folks. Reason why it's good to get these things started earlier. Very nice to be here with you guys, with everybody here on Friday, October 17th, as we get closer and closer to FluxCon. Today, I'm joined by two wonderful people that are going to be showing us Flux under the hood based on their respective experiences. We have Chris Mayenschein. Can you introduce yourself, Chris? Where are you located? Tell people a little bit about yourself and how you got into the Flux Explorers program.
I'm in the what's called the driftless area of Wisconsin. It's in the Midwest. It's an area that the glaciers never hit, so our terrain is untouched and pristine. It's kind of beautiful. Um, I've been in tech since professionally since the early 2000s. Been messing with writing software and everything since the 80s, even when I was a little kid. Um, I first I first was exposed to Flux a couple months ago, really. Um, I did system administration for about 10 years. I did programming for 10 years. I took a break to play with robotics, and I'm switching gears to come back to IT in the infrastructure sector. And I when I saw Flux and I saw what it could do for the content delivery, that was probably one of the coolest things that I had seen in a long time. Is It's one of those moments where you realize, oh, this is the stuff right here. This is really where things are going to be going. Um, so it's the whole Kubernetes thing is just I feel like a kid in a candy store learning all over again, like when I first got in. So I really been enjoying it.
Very good to hear. And we also got a comment in the YouTube chat. Someone is a big fan of the vertical mounted server, so good job on your background. We'll provide the audience. That's cool. No, that's
Thank
great,
you.
and very much hear what you're saying about the Kubernetes ecosystem. There's a lot to learn, as we said in the very beginning. You don't. No one expects you to learn everything all at once, and doing things correctly. By learning by doing, which we'll take a look at in a second. Our other guest today is Leigh Capili. Leigh, can you introduce yourself for folks who don't know you?
Hey friends, yeah, it's Leigh Capili from the Flux project. I've been around the Kube community since probably early 2015 or so, and was lucky enough to work with the folks at Weaveworks many years ago when we first turned Flux into what it is today, which is Flux 2. And so we can talk a little bit about how that happened and the shape of Flux. Today, I am a principal consultant and a maintainer on the project, and I work with Control Plane, who also employs some of the other maintainers. But we've got a multi-org project, and of course there are many millions of people using Flux on their clusters. So lots of folks interested in the changes upstream.
Very good. Now, one thing that we didn't do, we probably should have flipped a coin to decide who was going to go first. Chris, would you like to go first? Would you like Leigh to go first? And then you can add yours afterwards. What sounds best? Oh, I think you're muted.
Yeah.
No, Chris, you're muted. It's okay.
Everyone's got to do it sometimes. Yeah, I'm okay with going first. That way, Lee can bring in the stuff that I bring up and how it
Okay.
fits
Cool,
into
cool,
the
cool.
into the whole infrastructure a little bit better.
Great.
Let
Go
me
for it,
just
Chris. So share your screen. Take it away.
sure.
Folks, if there's anything that you're not sure about of what you see on screen, whether it's through the terminal or what we're going to be looking at that Chris will show us on GitHub, please let us know your questions in the chat and we'll get them answered accordingly, all right? So if there's anything you want to double check or anything you're not sure about, just let us know and I'm sure Chris as well as Leigh will be able to help you out. Take it away, Chris.
Okay, so we're sitting here. We got a standard, K3s install. This is nothing special. It's installation of K3s without the Helm installer enabled because Flux is going to take care of that for us, which is pretty cool. So we can bring up the pods here quick. So we got quite a few sitting here. There is this renovate pod, which is the key to my example here. Is what renovate does is it takes a look at your manifest, it looks at all your files, figures out what versions of the software that your pods are running, and if your pod is out of date, it's going to create a pull request on GitHub for you. So then all you have to do is go in, hit merge, and it'll fire up. So we're going to watch these commands every second. So now I'm running the kubectl get pods every second so we can see the stuff happening on the fly. And we'll do the same thing with the Flux Git customizations. What? Oh, I didn't have a 1 in there. Here we go. Okay. So here is the Flux Git customizations command running. It shows us, the different revisions that are in place. So like right now, we're looking at this D43. Oh, it just did a reconciliation check right there. So this D43 number, that comes back to the GitHub version. So that tells me that Flux is all reconciled with GitHub, and it's ready to go. Everything's doing the single source of truth. So we have that. There's a pull request here that was made by the Renovate app. And this is telling me, where's the note? So 2.14 is the new version. And right now I'm running 2.13. So it might be a security issue. It might just be a bug or something, but we want to fix that. And when we merge, go here, confirm merge. And then we flip back over here. This may take a minute. There's Flux isn't going to see it, every second that you make a change. It's however you have it set. If it's every couple minutes, every couple hours and whatnot. I got Flux set up right now to make the check every minute in order to, kind of hurry this along just a little bit more. So at this point, we just got to, kind of sit back and wait a little bit. It's going to fire through. Let me just make sure that is completely merged. Yep, there it goes. So now we have this reconciliation. It applied a revision to EEB. And down here, we've seen that notify pod was terminated and brought back up. There's a brand new one sitting here that's 15 seconds old. So now we're all up to date. We don't have any pull requests anymore because we merged it in. And, single source of truth right there running. You make an update to a single pod and everything just fires, automatically for you. And you don't have to log into the server. If I had, 30 servers all running that Notify app, I'd have to log into each one and update each one manually. This way, of a click of a button, then it's going. And that's pretty much the whole example there. There's not a whole lot to it.
This is a really good example, Chris. I'm very excited about what you're doing and what you're experimenting with. It's super cool to see somebody become savvy with all of the tools across the cloud ecosystem and within GitHub itself. And I think one of the coolest things that you're showing here is that you're collaborating with a robot. Because fundamentally, the problem that GitOps solves is not a technical one. It's a social problem.
Yeah.
Right? Like if you gave Renovate access to modify your computers, right, you'd have no say in the matter, right? But a robot should never be making a policy decision. And so because you are using Flux to create a source of truth, not for even just the desired state, but how you work on your infrastructure, you're turning GitHub into this place where decisions can be made. And that's really magical.
Yeah, I thought it was, when I first saw that, running, and I was like, oh, this is cool. I have to build that. And so, I sat down and, thanks to, the communities that I'm with and the mentors I have, they really, kind of give you a head start. And, admittedly, I have a bit of a head start because I've been using Linux for 25 years. So a lot of the underlying fundamentals are already there. And, that kind of spins me to, one of the big topics I do like to push is, if you want to get into DevOps, you want to get into doing all this cool stuff, you really got to start with your fundamentals, get your Linux down, understand what the commands are doing, understand the networking and everything. If you just, if you dive deep into the deep end of the pool without knowing how to swim, it might not be all that great of an experience for you. So,
Yeah, Leigh, would you echo that? Because I asked because I would say about 6 months ago, I did a podcast interview with someone who had written a blog that said Kubernetes is simple, it's just Linux, which is very controversial and stirred up a lot of debate on Reddit. But I think I'm just curious as to what, with what Chris just mentioned about Linux fundamentals being very helpful for anyone out there who's trying to learn Kubernetes. Leigh, what's your take on that?
I think one of the most frustrating things as a operations person is that when you learn all of the different facets of operating the different pieces of computing on Linux servers, like Chris was mentioning, right? So, getting your storage fundamentals, understanding how to operate services with systemd or Upstart or something, and then dealing with networking, which often is one of the first times that you have really frustrating experiences with hardware, right? Like plugging computers into each other, or getting a bunch of clients on Wi-Fi networks and things are not agreeing with you. It feels like you are learning 1,000 different things. And I think one of the reasons why people say Kubernetes is simple, even though it's really not, is that there is a uniformity to learning cloud native stuff, right? Like everything speaks this lingua franca of YAML in a similar shape, using an API machinery, right? A way of describing an end state that is similar across networking, across compute, and across storage. All of the things that we need to make computers work together so that we can get our jobs done and actually deliver a service that's valuable for people. But absolutely, like, I think one of the first things that people should get comfortable with is just being at home in their terminal. And you can see that, like, Chris is very at home in his terminal, right? Like watching multiple commands at the same time and seeing things change in the system in real time. Uh, it's just nice to have a little bit of dominion over your tools, for sure. If we spend our time at our tools, the time at the workbench is a lot nicer.
Hmm. Very well said. Good. Getting some good, nice comments in here in the chat, particularly from Chris Matcham. Thank you very much. And so yeah, so mentioning about the GitHub action that runs the dry run of the Flux changes in, feeds back into the PR. Awesome demo. So congratulations to you, Chris. Very good. Now, Leigh, what do you want to show us today?
I think I want to take an opportunity to talk about the different components that make up Flux. And then we're going to look at a little bit of source code, because I want to invite people to know a little bit about what's actually literally under the hood. Right, so I think
Okay.
Chris has done a great job of contextualizing the social problem that Flux solves. And I want to look at how it does that technically. Does that sound pretty fun?
Take it away. Yeah, and obviously, Chris, since you're here with us in the studio, if you have any questions that you want to just chime in while Leigh's doing it, go for it.
All
oh,
right,
fantastic.
I'm on one monitor today, so I'm just gonna
Okay.
minimize the streaming
No worries.
window.
Yeah. Well, if anything comes up. Yep.
Cool. All right. Um, oh, okay. I'm gonna be back in about 20 seconds here,
That's okay.
because the streaming platform has me switching browsers, and I need to give Mac OS permission to use my camera on this browser. So
That's okay.
maybe just stall for like 30 seconds. Sorry, folks.
Song and
Technical
dance. Let's
issues.
go. It's all good. It's Friday. It's okay. But I guess
I can take it.
Okay.
Just while we're on this, I know a lot of I interacting with a lot of people. I hear the whole thing. Kubernetes is really hard, or Linux is really hard, and I don't want anyone to feel discouraged by that or anything, because when you're looking at a mountain in front of you, and you see people halfway, three-quarter way up that mountain already, it takes it takes one step. Every time you make a step forward, you're heading up that mountain. And each step is learning something new. So don't be intimidated by technology seeming that it's out of reach for you. It's just a matter of time and learning the different things. So, I got years behind me of learning each different tool, and everybody else can do that too. It's just a matter of getting them down and taking those steps.
And it's very helpful, and it's exactly why we're here, and so that people don't have to feel like they're doing that alone. So I really appreciate you sharing that. Chris, also, we got a question in the chat. If you could share the repo link that you were showing on your screen.
I sure can. I'll put that in the chat
So yeah,
here.
when you get a chance, yeah, just drop that in the YouTube. Yeah, great.
All right, cool. I'm pulling up the screen, minimizing the
Okay,
studio.
Leigh.
Just yell at me if I need
Perfect.
to change something. And
No, it looks pretty good.
cool. All right. Well, when you pop over to the Flux documentation, or I guess this is the initial website, right? We talk a little bit about the problem that we solve. Okay, so you want to get started. You head to the docs. You can see that Flux integrates with a lot of projects. Right, so we have a couple of different ways of viewing a user interface or a state of the system about Flux. The one I'll be using today is actually not listed here, is a terminal UI tool called K9s. And then the only reason I'm kind of brushing on this is one of our principles with Flux is that the tools follow the Unix philosophy, right? So we build single purpose tools that solve their problem really, really well and interface with the rest of the ecosystem using standard interfaces, right? So with the Unix philosophy and Linux command line tools, tools do one job and they speak to each other over pipes with standard in and standard out, right? Just text streams. In the Kubernetes world, we have a bunch of open interfaces that tools talk over. And one of those is the Kubernetes API machinery. So my view is that the Unix pipe equivalent in the Kubernetes world is often the YAML file or how it gets serialized when you talk to the Kubernetes API server. Flux has a couple of components. And if you go to the toolkit components here on the kind of sidebar, you'll see there's now plural source controllers. So this is a brand new thing in Flux 2.7. I'll talk about that in just a second. And then there's customized controller, Helm controller, notification controller, and the image automation controllers. So this ends up totaling 5 plus another 2, 7 different controller components. Then when you add together this with the Flux command line tool, so you can see I'm getting Flux from Homebrew. You can also get Flux from a couple of other software catalogs, but for me, I'm on a Mac. That's what is that? That's brew info Flux, probably. Yeah, you can see this comes from our project. Nope, this is. I think I have to say something like Fluxity tap Flux. There we go. Not in FluxDB. There's a lot of different projects out there. So you can see you can get the Flux CLI tool directly from our brew tap. And that gives you a couple of different subcommands. But we've got our controllers, we have our CLI tool, and then lastly, we have the Flux operator, which you can get to our docs site and our repo. This is under the control plane org. It's licensed open source. And the Flux operator has its own kind of introduction installation. And this is something that we're pushing in the project, encouraging folks to manage Flux a little bit more in a sophisticated manner than before. Now, there's the different components here, and you can see each one of them has a little architecture diagram. I think we're still working on one of these for the new source controller that we've added in Flux 2.7. But the whole idea is that you have a controller that's really good at one job, right? Watching Helm repositories, watching buckets, watching your Git repos, and then pulling that state into the cluster. Once that state's in the cluster, it can hand off, the job of applying the desired state to something like customize controller. Right, so customize controller will go and talk to source controller, right? And that desired state has been fetched into the cluster. Now it's going to, realize your namespaces, your custom resource definitions, and your deployments into the cluster. Great. So there's, again, sort of the four main controllers: source controller, customize controller, Helm, and notification controller. Optional components: image reflector, and image update automation controller. And then there's the new one, which if you scroll down in the source controllers section, we have source watcher. Source watcher is a new controller that lets you compose sources using this artifact generator API. So the use case here is to take multiple sources once they're in the cluster. Say you want to combine 2 Git repos and an OCI repo into one thing, or you want to take a OCI Helm repository and a values file from a Git repo and you want to stack it on top of it, you can do that. There's another huge use case here, which is actually decomposition. A lot of difficulty with performance. It's not unusual for a team to have a couple of mono repositories, right? Big Git repos with lots of state, potentially hundreds of dev teams working on tens of thousands of applications in a microservices environment, where Flux is running on literally thousands of Kubernetes cluster all over the world, right? Like this is not an unusual scenario. It's, of course, a very large scale use case, but there are many installations of Flux on Earth right now that could be accurately represented by that kind of scale. And some of those users put a lot of state into a single repo. And traditionally, people have had to decompose their repositories into individual pieces themselves with their infrastructure. And this puts a lot of load onto your dev team socially. It also puts a lot of load onto your Git infrastructure. And then it's really difficult to figure out how changes are decoupled from each other, right? So if you change one file in one folder, how do you know that it doesn't have an effect on stuff in a different folder? So Source Watcher actually lets you take mono repositories and then split them up inside the cluster after they've ended up in the cluster into different pieces. So just a kind of cool use case there. So what does it look like inside of these things, right? So I told you I was gonna, I have a cluster here running a non-trivial application. It's got a couple of OCI repositories feeding into the state of the cluster. So here I'm doing a concept called gitless GitOps, where the cluster is not actually dependent on state that comes directly from Git. It's being instead packaged into a signed OCI artifact and then pulled into the cluster. When you run flux get all, your default namespace that you're looking at things in is the Flux system namespace. And then here you can see that there's also a Helm release that's managing Flux operator, which itself is managing Flux, which itself is managing the Helm release, which is managing Flux operator. So, you have a fully GitOps, a full GitOps entry point to manage any of these components. And then we set up our system state and our tenants. If I expand the namespaces to everything in the cluster, you can see that we're doing something quite non-trivial here. So there's a bunch of different OCI repos: cert manager, chart, my declared infrastructure. You can see I want some apps and infrastructure to deploy into the cluster in a couple of different namespaces. That's going to break out into tenants. There's a front end and a back end namespace. We're running a Nats cluster, all kinds of stuff, right? This is what Flux is really good at. I actually only am responsible for producing part of this state. Many of my other teammates have collaborated together in Git repositories to get to this desired state, and I'm iterating on it as an app developer, as somebody who knows a little bit about infrastructure. So this is the use case of Flux. But if we look in the Flux namespace and we get the deploys for the Flux system, you'll see that there's a couple of controllers. So Here we have Flux operator, and then I'm just running the 4 main controllers of the project with no optional components. Right. I want to take this moment to open the floor for people to interrupt me with any questions. But what I really want to do is then, after some questions, get into a little bit of looking at the source code of these controllers just to show you how stuff works. Is anything in the queue, Bart?
Yep. So Chris Matcham asked, sometimes we have to separate the Git repo for CRDs and operators. Could I use Source Watcher to combine them, but still include the dependency?
Yeah. So you can do. You would probably still in that scenario have your depends on between 2 customizations. It's a little context on what Chris is asking about here is like if you want to apply a custom resource to a cluster and the cluster has not been programmed to even talk that API definition yet, that's what the custom resource definition lets you do. It lets you teach Kubernetes how to speak, how to write, update, read, delete a new kind of object. And that has to happen in an order. How do we express that in a way where the Git repo can apply to the cluster, without errors? And normally in Flux here, you would, in your Git repo, make 2 folders, one for custom resource definitions, and then one for the custom resources that are supposed to come afterwards. And then if you're doing this for multiple components, you would probably nest this kind of controller installation, which has the API definition, and then the controller resources into different places. The composition and decomposition features of Source Watcher are absolutely helpful here. So say that you wanted to have a template where you install Cert Manager, and then for your organization, whenever you install Cert Manager, you create a wildcard certificate. So you have a base repo for that. And then for my project, I also want to stack some additional certificates onto there and change the Cert Manager config. I can do a Helm value override from a separate Git repository or OCI artifact or bucket, and then pull in my new Helm values that I will merge onto a file. And then I can also add my additional certificate resources using source composition. And since the structure would have already been there in my template for the dependency, I wouldn't even need to worry about it. So that's a really great question there. Lots of different ways that you could see using that mechanism. Cool. So Bart, when do we want to stop the stream here?
Oh, you can keep going.
Cool. I'm hopping over into my local copies of repos that I have in the FluxCD org. And I'm just going to see if I can open VS Code for like a lot of these different repos. We'll make sure that the font size is nice and legible for folks. Okay. So the first thing that I just want to look at is the loop of a particular controller, right? So let's hop into Customize Controller. And you can see that this is a Go project. Many of the projects in the cloud native ecosystem use Go. It's one of the reasons why it's so easy to integrate with a bunch of different projects. And if you hop into the main here, this is the starting point for Customize Controller. You can see all of our dependencies, and then you can see that we set up a bunch of options and flags that we get from the command line when you actually begin Customize Controller inside of its pod. Then we set up a bunch of options for you to override. Then there's this controller options structure. Controller options lets us use the Kubernetes controller runtime to set up a controller manager. And to that manager, we're going to add our controllers, which have reconcile functions for different resources. So Customize Controller's main resource that it watches is the customization, right? So you can see here, we set up a cache by object that selects if there's some selector that you're limiting, like say you're doing sharding with customized controller, you have a couple different installs of customized controller for high scale. This is kind of where that gets limited. You set up the controller, you constrict it to some namespaces, and then you make a manager and get it all kind of started. So there's a lot of boilerplate here that then is intensely customized because we have 10 years of history around why Flux needs to work a certain way. You can see that we pull in our ability to use like a metrics handler this is where we export our Prometheus time series metrics so that you can observe Flux. That means in practice that I think I have a port forward. How do I look at my existing port forwards? Show port forwards. No, there's no port forward defined. I can do this 1 second. Just got to figure out what I was trying to actually show here. It was like almost in the flow. I think if I just go to localhost 3000, I have Grafana here. Yep, there's a couple dashboards. So like here's the Flux control plane. Cool. Took me a few seconds. Thanks for sticking with me. Here, you can see like just the time series metrics for our CPU usage. Here, this is Kubernetes API requests that are specifically scoped to Flux. You can see when Flux does its reconcile events. What else do we have in this other dashboard? That was control plane. Here's the cluster stats. Yeah. So you can see Flux itself knows the counts of the objects that it's watching and what states they're in. So we bundle all of these metrics up for you. That's what the metrics handler is for. Right, so that's like the value of controller runtime. Let's go ahead and look at the reconcile func, which I got this. We should be able to just go into internal controller, and then we've got the constants, customization depends on. This is our test func. It's getting a little hard for me to stay oriented at this font size. Sorry, friends. Here's the inventory management. Because I opened every. Files to include customize controller, and let's can feel a little silly right now because I'm fumbling a bit. Here we are. Here's the reconciler, and here's the reconcile func. Okay, we're back. We're oriented. So here we are reconciling customizations, and you can see we've got some helper funcs. I think there is a lowercase here. So we need to actually make a temporary directory, render some manifests to disk, fetch those from source controller itself. You can see we have some like overrides here for doing local testing. And there's a bunch of concerns here, right? This reconcile function is actually pretty long and calls out to a bunch of other sub-functions because customized controller is probably one of the highest featured pieces of Flux. It is a way for you to validate your resources before they're sent to the cluster as an atomic unit. It goes through a couple of different apply phases for every time you have a desired state. It needs to impersonate a service account so that it drops privileges from administrator to something that is well scoped so that you can enforce delegated ownership of different pieces of the cluster and different resource groups inside of your cluster to different people in your organization. That's this section right here of code is the technical function by which you get the social capability of trusting that a folder inside of Git is safe for your developers to use. it's constrained to the namespaces that they own and to the resources that they're supposed to touch. Similarly, it's the thing that helps as an infrastructure team that this policies folder is not going to overwrite an application, even if you accidentally put something in there that it was not supposed to be. So, like, it's cool to get to the source code and tie that back to what what does this technical function let the end users, like the people who trust and depend on Flux, the the folks who deploy this in their organizations, and they need this set of continuous delivery controllers to do its job. How are these features actually implemented, and what can you do about them to evolve them as we go into the next decade of Flux? So that's kind of the gist of what I wanted to get at, right? There is 4 core controllers. I'm just going to stop sharing my screen here and let's zoom out a little bit, right? So Flux has 4 core controllers. And even if you used Flux with all of its options, it's incredibly lightweight. The way that we encourage people to use Flux is a single Flux installation in every single one of their clusters. All right. So if you've got hundreds of clusters, Flux needs to be small and lean, and it needs to run close to the infrastructure, close to the API server. And we don't want it to use lots of resources. And that's why each controller does one job. Right. Helm controller's job is a lot bigger of a job from an API surface and performance perspective than source controller. Source controller just has to fetch some stuff in. So Helm controller, customized controller, source controller, notification controller, that gets you running. If you want to do some image automations, image reflector, image update automation controller. And then if you want to decompose and compose sources from monorepos, or maybe pull multiple things and soft fork stuff at runtime in your cluster, source watcher. If you want to manage Flux in a declarative way from a Gitless source, trusted distribution, like say the upstream artifact or Flux Enterprise itself, Flux Operator, which also lets you use a resource set to do dynamic templating from GitHub branches and pull requests, all kinds of stuff. It's cool. Time-based deployments, Flux Operator. 2 CLIs, the Flux Operator CLI and the Flux CLI, which lets you do a bootstrap. Lots of fun components across the projects, and all of the code is open and it's available on GitHub for you to clone, fork, contribute, build yourself, build your own interfaces, extend. You can build your own controllers on top of this external artifact that API that we've just shipped in 2.7. Getting a little bit deep, and I'm really trying to zoom out, so that's kind of what the project looks like under the hood. And I just want to invite all of you who are watching to continue learning about the different pieces, employ the Flux controllers in your own workflows with your own teams, collaborating to accomplish what you want on a cloud native infrastructure, and get involved and contribute. We have the Flux dev call every single week, alternating time slots from US and EU time zones. Bunch of people there who are regulars, and then we always have some folks popping in and asking questions or advocating for their issues that they are running into. You can find us there every single week without fail. So, come and be a part of this. It's so humbling for me to be coming up on a decade of working on this software, and I can't wait to see what happens next in the next one. So,
very cool. And thank you for sharing all that, Leigh. And as you said, it couldn't be easier to get involved. Check out one of these calls. You don't need to be an expert. You can be there just in the background, listening, getting informed, getting your questions answered. So keep that in mind, regardless of the time zone. Like you said, it alternates to be convenient for folks to attend. Just while he was explaining the stuff that he was explaining, Chris or anyone else who's in the audience, if anybody has any questions, feel free to share them now. Leigh is also very easy to find on LinkedIn, on Blue Sky, CNCF Slack, Kubernetes Slack, and lots of other places. But yeah, Chris, any questions that you'd like to ask Leigh, or if not, we can take this offline and keep the conversation going.
I think that was pretty good. Your presentation was awesome. I found myself getting a little distracted because I was reading the code too while you were talking about it. So, coming from a software
that's the whole
background,
point, right?
yeah,
It's getting just a little taste of what it looks like to wield control of these tools. And it all starts in the repo. Anybody can do it, for sure.
Great stuff. Well, that being said, we can wrap it up for today. Amazing conversation. Thanks both to Leigh and to Chris for sharing their time and knowledge with us. We'll be back next week and gearing up for more, looking at, closer look at Flux. We have the last episode of the Flux series coming out next week. Episode 4, we'll be hearing from different folks at Mirantis, at GitLab, and Microsoft about their experience building with Flux, taking things to the next level. So you'll be able to check that out next week in terms of content that will be coming out about Flux. And then we will continue the conversation next week. I'm hoping to get Nick Eberts from Google to come on and share his experience, and to get some other folks. I think Chris Matcham is also gonna show us how he makes the cool videos that he's been sharing on LinkedIn. If you haven't checked out his videos, they're really, really good in terms of how he shares knowledge, makes it really accessible, easy to get into. So yeah, that being said, folks, have a wonderful weekend. Thanks again to Leigh and to Chris, and we'll speak to you very soon. Take care, everybody. Cheers. Bye.